So throughout the manufacturing process of the component, you can see it's got quite scratched. And we're over here at the surface plate. So what we're aiming to do is we're going to get rid of some of the surface imperfections, and then eventually, using our DTI, we're going to be able to test for runout and emery out that runout on this component. So we're starting with quite a coarse piece of emery. So you need to keep your surface plate, you need to clean it after you've done these operations, purely because the grit will stay on the surface plate and will scratch it. So this is a cast iron surface plate which was hand scraped in, and there's only about 1/8 of a thou run out in this plate, so it should be alright for a small component like this. So we're going to start just by rubbing the component on our quite coarse emery paper. We're then going to go on to our slightly less coarse emery paper until we're onto glass paper to develop that mirror finish on this component, because this face and the face of the engine will meet, and yes, arguably there is a gasket between them, but the two faces do need to be quite true to ensure a good seal, and also it does improve the appearance of the component as well. So you can see already we are starting to remove some of those surface scratches. And yes, we're replacing them with scratches from the emery paper, but as we remove up the grades, those scratches will get finer and finer until we're eventually onto our buffing wheel, where you really won't be able to see those scratches, and we'll have a really nice finish on this component. So you can see there, we're really getting quite close, but you can see where it is as to where we're removing it. So to show up the high spots, what we're going to do is, a bit like when you use engineer's blue, you can simply put any form of ink on the surface, and then as we emery we can seal those high spots and where slightly more work is needed. And the advantage of doing this is you can see those high spots and you can visibly and physically work those a little harder. So we're able to remove all the surface imperfections, and we're able to see where the high and low spots in this component are. So we'll join back in a second when that's dry, and we'll continue. So now, having gone over both sides with the 60 grit emery paper and inking both sides to remove all of the high spots, we're now going on to a finer emery paper, but we need to make sure we clean the surface plate in between with either a water displacing chemical or something that's going to remove all the dust. So now going on to the finer paper, we're going to repeat the process, and then in a couple of minutes we'll then be over at the polishing machine ready to finish them up and get that mirror finish on the components. Hello again, so this is another quick update on the pump, but also what might be a future project. So there's the pump cylinder, all drilled and bored. While I'm not making these little engines, I do actually help to maintain a 1937 Lancashire boiler. So it's had a few teething problems recently. So the ratchet mechanism, which works the auto stoker, spring stoker feed, looks like this. So it works like a very simple ratchet and engages on an angled gear, like shown in this crap drawing here. So that's a very basic engineering drawing of the piece we're going to be making. So here's the original, and along with being very rusty, it's also very worn and seems to have been the victim of some quite crap engineering at some point. So the problem we have is this piece here engages in the gear, this tang on the top, and if you can see by the side, it's actually slightly more shiny than the rest of it, and that's because it's been built up with weld, but as you can see with a file, it's actually quite hard. So this would be fine if the gear we were pushing on was as hard as this, but it's not, it's quite a lot softer. And with it being about a 10-inch angled gear, it wouldn't exactly be fun to make another one. So this part, sadly, is kind of rendered useless. And if you look at the difference between the original part and the casting is sufficiently bigger on this part here, so it'll have a greater counterweight, therefore being a bit more efficient. So originally this would have all been one piece, but it's been built up where it's worn away. And on the other side of it, there's this. This runs along a beam which lifts it up and presses it down. So it sits like this. And as we had castings made for one, we might as well have done for the other. So there's the other casting. It's all held together with a 1/2 inch Whitworth thread, which you can see on this one there. So we'll make a stud, sink it into this one, and then make 2 new nuts out of this hexagonal bar. This probably won't be a very long project, but it'll be one nonetheless. So if we actually measure 1 or 2 of the castings, we'll see they're actually quite a lot oversized compared to the original. There'll only be one other major sort of thing we won't be including, which is, if you see on this one here, it's actually got a bronze bushing inside it, and that's because it's worn out at some point, and like I said before, it's not been the victim of the greatest repairmen in the world. It's worn out and then been probably repaired to the cheapest method possible. So with it being a rough casting, we're not too sure on the initial measurements. So taking off the drawing I've already made, as you can see in that there, we know the hole spacing is 4 inches. So instead of marking it out from set distances on the casting, I know that we can simply mark a single point on this side, and then marking 4 inches across on this side, we then know where we'll be at. So it'll probably be a project involving a bit of lathe and milling work, but it'll be quite interesting to mill this profile here, because we've already measured it and it's a 45-degree angle. But if we can just check it with the calipers, there and then there, you can see there's quite a lot of material to come away. But unlike the other one, this one, when we get it on with the file, is actually just soft cast iron. So it'll be quite an interesting machining job. Thank you very much for watching. Goodbye.